Hi, this is Dr. V.S. Nishad from AC Department, SNS College of Technology. Here we are going to discuss the topic comparator from the subject linear integrated circuits. Okay. What is the need or what is the purpose of comparator? Comparator compares the given input signal with a reference signal and provides the result based on the comparison of the two input signals. So here the outputs are shown in ideal characteristics in figure A and practical characteristics in the figure B. So if you see, the outputs are represented as plus Vsat and minus Vsat in the figure A. So whatever output in the positive terminal, positive peak value, that we represent here in the comparator as plus Vsat, and whatever output in the negative terminal, that we represent as the minus Vsat. So if you see the figure A, we can identify there is a sudden change from the output from plus Vsat to minus Vsat or minus Vsat to plus Vsat. So it is only the ideal characteristics, but when seeing the analyzing practically, we can see a change in the output with respect to the input with some delay as shown in the graph B. So here there won't be any sudden change, but after some time period there will be a change in the output. So this is the figure B is the right one. And coming to the types of the comparator, we are having two main types, that is based on the operational amplifier, that is where we are connecting the input. Based on that one, we are having inverting comparator and non-inverting comparator. So non-inverting comparator, so here if you see, the input voltage Vi is connected to the positive terminal, that is non-inverting terminal, and then the reference voltage is connected to the inverting terminal. So here the output is measured based on the two main condition. So whenever Vi is less than V reference, since Vi is connected to the non-inverting terminal and V reference is connected to the inverting terminal, here we are considering the two conditions. The first one is Vi less than, if the condition Vi is less than V reference, then the output V0 will be equal to minus Vsat. So in the non-inverting comparator, when Vi is less than V reference, then our output will be equal to V0 equal to minus Vsat. So in the same way, when Vi is greater than V reference, when Vi is greater than V reference, V0 will be equal to plus Vsat. So this is the two main condition we need to consider for non-inverting comparator. So let us see the graphs based on the two different reference value. So in the left hand side, we are taking the V reference as a positive value, and in the right hand side diagram we are taking the V reference as the negative value. So if you take the V reference value as the positive value, in the input sine wave signal, that is in the analog input signals as a sine wave, we are taking the V reference, let us consider as plus 1 volt. So when as per the previous condition discussed, whenever Vi is greater than V reference, the output will be plus Vsat. Whenever Vi is less than Vsat, output will be minus Vsat. So that is proven in the left hand side square waveform, output waveform, and when comparing it with the minus V reference value, the same way, whenever Vi is greater than V reference, output will be the plus Vsat, and whenever Vi goes lesser than the minus V reference, the output will be the negative Vsat. So that is the case for non-inverting comparator. So while coming to the inverting comparator, so the input voltage, here the input voltage will be connecting to the inverting terminal, and the reference voltage will be connecting with the non-inverting terminal. So that is the difference between the inverting and non-inverting comparators. So here the input is connected to the inverting terminal, that is why it is named as an inverting comparator. So here whenever while comparing the graph with the non-inverting comparator. So here if you see V reference, same way we are taking plus V reference, that is plus 1 volt and minus 1 volt. In the left hand side, if you see the graph, at the top sine wave input signal, the V reference is taken as a plus 1 voltage. So if you are seeing the diagram, we can see the whenever Vi is greater than V reference, the output will be minus Vsat, and whenever Vi is less than V reference, then output will be the positive Vsat. So that is the case because of the change in the input terminal where we are giving the Vi value. In the same way for negative V reference value also. So this is the case for two different comparators that we have discussed till now. So coming to the advantages and disadvantages of the comparator circuit. So going for the advantages, simplicity, cost effectiveness and easy implementation are the main advantage of the comparator circuit, and then high input impedance and low output impedance, and then high gain because we are using the operational amplifier as the comparator circuit. We are obtaining high gain at the output path and improved DC precision such as low voltage offset and low noise. And then coming to the disadvantage part, it consumes more power when compared to the other circuits, and also slower switching speed. So that is less slew rate when compared to the normal comparators. So that is the two disadvantages of the comparator. And then coming to the application part, some of the important applications of the comparator are zero crossing detector and window detector, time marker generator, phase meter, A to D converter. So these are some main applications of the comparator circuit. Here we are seeing the circuit diagram and input output waveforms of the zero crossing detector. So here if you are seeing the input waveform, that is we are taken as a sine waveform, and the output, that is switching between the plus Vsat and minus Vsat, shows represents the output as a square waveform. So we can simply mention as a square waveform generator. We can simply mention the zero crossing detector as a square waveform generator because the sine input wave is converted into a square output wave through this zero crossing detector. So that's all about the today's video. In this video we have seen about what is the purpose of comparator and what are the types of comparator, and we have start seeing about each diagram, that is circuit diagram of each both inverting and non-inverting comparators and its respective input output waveforms, and what are the conditions for changing the input from, that is output from one state to another state. So I'm coming to the advantages and disadvantages part, and finally we have concluded with the applications of the comparator circuit. And coming to the assessment, here we are having the two questions. Starting with first one, depending on the value of the input and reference voltage, a comparator can be named as voltage level detector, and then zero crossing detector is also called as a sine to square wave generator. So that's all about the comparator circuit. We can see in the next video.